Good evening, everyone. So I think today is a little late. Class became a little late. Yeah, can we start now? Today's class. Start the today's class. Right. Let's start the today's class. So I'm starting now. Yeah, perfect. Thanks for your patience. Right. So I'm starting now. Everything is all right. Everything is all right. I'm starting. Thanks everyone. So yeah, let me start now. I'm starting. Yeah, I think verify is it everything is okay or not verify? Yeah, perfect. So let me start this. So merge sort algorithm, right? In today's class, we are going to discuss merge sort algorithm, right? We are going to discuss about this, right? So let's start now. Merge sort, and I want to clarify one important thing. One important thing I want to clarify, right? Careful. So the DSA course, this DSA course is designed for this DSA course is designed for campus placements also, and gate also, both, all competitive exam. It is designed for all, right? Gate also, placements also. It is designed for all. It's one of the famous algorithm. Merge sort is one of the famous sorting algorithm. Careful. It's one of the famous sorting algorithm, right? And DSA, the course whichever are started now, right? It's going to be right. Let me say this one. 2 months total theory will be completed. 2 months, and 2 more months practice. Then within 4 months, right? Within 4 months, you will be perfect with the DSA course. You can easily crack any campus placement. You can easily crack any campus placement. You can easily crack. Within 2 months, algorithm, data structure, both will be completed. Algo, DS, both will be completed. 2 more months, 500 practice problems we will do. Right? 2 more months, 500 practice problems we will do. Small problems are 100. Right? Medium problems are 300. Right? Tough problems are 1 more 100. Totally 500 problems will be done. So if we can do this, this DSA will be successfully completed. Today we will discuss about merge sort algorithm. I'm starting now. Today's date is 8th. Today's date is 8th. We are going to start the merge sort algorithm. Careful. We are starting the merge sort algorithm. Make sure everyone will get it. Whatever I'm going to explain, right? Make sure everyone will get it. So I'm starting now. Merge sort algorithm. I'm starting. Remember everyone. Merge sort algorithm. I'm starting. It is one of the comparison based sorting algorithm. Merge sort is a comparison based sorting algorithm. Means what is the meaning? Right? While sorting, you will compare the elements. Sorting algorithms are two types: comparison based, non-comparison based. Right? Sorting algorithms are two types. What is the first of all sorting? Sorting in the sense arranging the elements in the either ascending order or descending order. I have some elements. I want to keep them in the ascending order or descending order. That is called sorting. So to sort the given array, one way is merge sort. Merge sort is the one way. Merge sort is the one way to sort the given array. And one more, while sorting, by comparing elements, you will sort. So it is a comparison based sorting algorithm. It is a comparison based sorting algorithm. And one more, while doing the merge sort, you will do the division. I have one array, I will divide. So it is a divide and conquer sorting algorithm. It is a divide and conquer sorting algorithm. And one more thing is, right? So in the gate examination, many questions came in the gate exam. In most of the placement, right, interviews also, you will find this algorithm, right? This merge sort algorithm you will find out in competitive examination. Many places you will find out, and one more in the right in the campus placements also. Big companies, Microsoft, Amazon, right? Uber, Ola, right? So many companies, right? In the campus right? In the interviews, you will see about the merge sort algorithm. Right? This is the I can say I can say this one. It's a classic algorithm. It's a classic example of DSA. In the DSA, right? In DSA, some questions, I think, suppose in that 500 questions I'm going to do practice. DSA course 500 problems I'm going to do practice. Remember, using this merge sort algorithm, at least in those 550 questions we can solve using merge sort algorithm. So some people are asking, sir, what can I say about the merge sort algorithm? It is a comparison based sorting algorithm. First of all, what is sorting? Arranging the elements in the ascending order or descending order. Arranging the elements in the ascending order or descending order, that is called sorting. It is a comparison based sorting algorithm, because by comparing elements only you will sort. Sir, without comparing, how can I sort? There are some sorting algorithm. Without comparison also you can sort. Those are going to be non-comparison based sorting algorithm. That is a radix sort will be there, bucket sort will be there, counting sort will be there. There are many. Right? Merge sort is a comparison based sorting algorithm. It is following the designing technique, divide and conquer. Many questions are there in the gate examination from this. Most of the campus interviews, most of the interviews, placement interviews, you will see about the merge sort. 50 questions out of 500 which we are going to discuss. Out of 500 problems which we are going to discuss, approximately 50 questions are based on the merge sort algorithm. Right? Please be careful. So some people are asking, sir, what exactly, how this algorithm will run? Right? See this one. So normally divide and conquer means first you will divide, next you will do conquer, next you will do combine. Right? Divide, right? Conquer and combine. So combine means merge algorithm. Divide means divide algorithm. Conquer means recursion. Here recursion will be there. Here recursion will be there. Right? So this follows the divide and conquer technique. That is okay. Now see the algorithm one little bit. See this one. Merge sort algorithm is mostly like this. First divide. So you have one array. You have one array. First to divide. That is the first step. Array contain n elements, right? First divide into n by 2, n by 2. First divide. Okay, I divided. Next one, right? So if you want to sort this entire array, you divide into two parts. Na? First sort this half. Next sort this one more half. That is the next one. Conquer by recursively sorting both the halves. Using recursion, sort the left half. Sort the right half also. Next one, right? When you done this, when the second step conquer is over, the left half is already sorted. Right half also already sorted. Now using combine algorithm, means using merge algorithm, sort the total array. Sort total array. Sort total array. This is the merge sort algorithm, right? Combine by merging the two sorted arrays. Remember, combine algorithm is called as merge algorithm. Remember, is a very important one. Remember this one. Division cost is negligible. Why? Simply you are dividing just one division. Suppose 100 elements are there, 100 by 2, 50, 50. Time complexity means loops required. So when you divide, where is the loop? So division is negligible. Division cost is negligible, but merging cost is more. How much more? N by 2 elements, N by 2 elements you are merging. So merging time is going to be n time. So this will take n time, this will take constant time. So if I talk about in terms of algorithm, this is the some pseudo code I given here. What is that one? First to divide. This is called divide. This is called divide. This is called conquer. Solving sub problem using recursion. That is called conquer. This is called combine. Merge algorithm is called combine algorithm. Merge algorithm is called combine algorithm. It is the divide. It is conquer. So you know very well in the divide, if you see, there is no algorithm, nothing, constant time. If you see conquer recursion, which will take 2tn by 2 time because of two halves. So total array, assume that total array sorting will take tn time. First half will take tn by 2, second half will take tn by 2. Combine algorithm, right? One loop is there. See, it is a merge algorithm. It's a one function call. If you go inside that function call, some story is there. Merge algorithm, right? Which will take n time. So if you see some example also I planned here. See this one. One example also I planned here. Let me check what is that example, right? I will try this. See the example. Everyone see this. Everyone see this one. It is I think array A 1, 2, 3, 4, 5, 6, 7. Right? So 7 elements are there. Array A which contain 1 to 7. You want to sort. First to divide. So 1 plus 7, 8 by 2. Think someone is singing. Right, next one. So a1 comma 7, a1 comma 7. First to divide. So I think 1 plus 7, 8 by 2, so 4. So array A which contain 1 to 4. Sort left side. Array A which contain 4 plus 1, 5 to 7. Sort this. Right, so first to divide. So this is called as divide. But remember, what is the meaning of conquer? Same thing will happen on the sub problems also. A1 comma 4, again divide. A1 comma 4, again divide. 1 plus 4, 5 by 2, 2.5. So take the 2. Array A which contain 1 to 2, first to sort. Array A which contain 3 to 4, sort this. Same thing here also. Array A which contain 5 plus 7, 12 by 2, so 6. 5 to 6. So array A which contain 7 to 7. One element means you can stop. Here two elements you divide further. A1 comma 1. A2 comma 2. A3 comma 3. A4 comma 4. A5 comma 5. A6 comma 6. Right, like that. So divide, 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 divide. So divide is one. Remember, this is called divide. Recursion, na, everywhere divide. This is called divide. This is called divide. This is called divide. This is called divide. So divide is there. So how many times you divide, na? Those many times you have to do combine also. Let me do combine. What is the combine? Combine means, right, left people, right people, you have to keep in the sorted order. I will try once. I will try once. Let me use another color. I'm using the black color. See this one, combine. See this one, I think left one element. What is the first element? 38. Right to second element. What is the second element? 27. Combine. Now I am doing combine. Remember, combine is nothing but left one element, right one element. After combining two elements in the sorted order, it became 27, 38. It's called combine. Same way here, A33, A44. What is the 33? 43. What is the 44? What is the 443? Combine, right? One element plus one element. It will become two element in the sorted order. 3 comma 43. So I think here combine is over. Here also combine is over. You got it, right? In the similar way here, A55. What is the fifth element? 9. What is the sixth element? 82. If you combine 9 and 82, if you combine 9 here, 82 here, it is also done. So next one, 7, 7. What is the seventh element? 10. So I think left two people, right one person, 2 plus 1, 3. Total 3 people in the sorted order, right? 9, 10, 82. Remember, combine is nothing but, right? Combine means merge algorithm. Merge is nothing but left how many people, right how many people. After merging, total people will come in the sorted order. Again, I am combining here. See, remember, this reverse is called combine. Left 2 people, right 2 people. After combining 4 people in the sorted order, 3 here, 27 here, 38 here, 43 here. Combine here also over. Now see this one, left 4 people, right 3 people. After merge algorithm over, means after combine over, 7 people in the sorted order. So what is the answer? 3, 9, 10, 27, 38, 43, 82. So sorting is done. So remember everyone, this is called divide. This is called combine. When you are combining, all elements you are taking into consideration. When you are dividing, simply divide. 8 elements become 4 this side, 4 this side. If 7 element, 4 this side, 3 this side. Right, so same thing I explained. So divide. So this entire thing is first divide here. This also divide here. This also divide. This is the divide story. Until one element will come divide. Next one, see the combine is going on. See this one, combine is going on. It is a final combine. It is a final combine, right? Initially maybe, right? So I think bottom you will be here. Lastly, this is the final combine. So the total procedure, whatever you do, this is called conquer. This is called conquer, right? Next one, divide here, combine here. Please be careful. So divide time, how much? Simply division, right? Simply divide. So let me write now, time complexity, recurrence relation. Time complexity of the total program Tn is equal to, divide is constant, conquer is 2 halves, na, 2t n by 2. Combine is, I think, left half, right half, n people, so n time. So if you simplify it, you will get this. using master theorem or using substitution method or using recurrence tree method. So you solve whatever you want. If you solve this one using master theorem, you will get the n log n time. Time complexity of the merge sort is n log n. So best case, right? In every case you have to do same, right? Best case time complexity is best case also n log n, average also n log n, worst case also n log n, right? So it is independent of the input. Whatever input you will give, it is same. Space complexity, I think you are dividing every time, divide by 2, so stack space is required. Every time dividing by 2, stack space is required. I think right, if you divide by 2 log n stack space. But whenever merge algorithm is going on, you will take another array. Merge algorithm going on, another array you will take, order of n. So finally it will go to total space is going to be n plus log n. N plus log n total, finally n is the space complexity. N for the merge algorithm auxiliary array, log n for the stack space, right? And one more, because of this n, if the space is more than log n, extra space is more than log n, it is not in place. Merge sort is not in place. What about stability? Repeated elements order will not change. So it's the merge sort is stable algorithm. Merge sort is stable algorithm because repeated element order will not change. It is not in place, right? In place or not, it is not in place because you are using more than log n space, more than log n space you are using, which is nothing but n you are using. So it is not a in place algorithm. And one more, comparisons with other sorting algorithm, right? Comparisons, if you see the merge sort, if you see the merge sort, this one, if you see the merge sort algorithm, time complexity n log n, space is n. Space is n. And is it stable? Yes. Quicksort algorithm, if you see, worst case n square. Space is only log n. It is stable? No. Quicksort is not stable. If you see the heap sort, time complexity n log n. So if you see the space complexity, right? Space complexity, if you observe, within the array you are doing. Within the array, there is no recursion, nothing. Within the array you are doing. Within the array only you are adjusting everything. Space is one, it is the stable, right? Stable. Repeated elements order. Repeated elements order. Let me check here. Stable, repeated elements order will change. That is the reason it is not stable. What about insertion sort? Worst case n square. Extra space you don't take. Is it stable? Insertion sort is stable? Yes. Insertion sort is stable, right? Please take care about this one, because of at a time comparing is going to be little tricky because of many times I done, right? I confuse a little bit. You please take care. Stability. And one more thing is in place. Space is more than log n means space more than log n, it's out place. Space is more than log n, it is out place, right? Recursion tree analysis, height is going to be n. Recursion tree analysis, work at each level. So recursion is one, height of a tree is log n, workspace, right? Everywhere combine is there n. That is the reason time complexity became n log n. Right, next one, some people are asking, what about number of comparisons? Number of comparisons. Whenever a merge algorithm is going on, so left half, right half, you are comparing. Left m people there, right n people are there. So every element, one comparison is required. So m plus n comparison. But for the last element, no comparison, -1. This is the worst case number of comparisons. What is the best case? Best case is minimum of m comma n. Best case is minimum of m comma n, right? It is a merge algorithm, right? Merge algorithm comparisons are these many, which is nothing but a merge sort. Number of comparisons, worst case is if m comma n is there, m plus n -1. If at all n by 2 there, n by 2 plus n by 2 -1 means n -1, right? So total comparisons are n log n. That is the reason time complexity became n log n. And one more thing, remember, merge sort is very good for linked list because extra space is not required. It is good for linked list. Merge sort is good for linked list, not for array. Linked list is going to be good, right? So best sorting algorithm for linked list, right, is going to be, right, best sorting algorithm in linked list is going to be merge sort. It's going to be merge sort. That's what you want to say this. So many questions are there in the GATE examination. So many questions are there on merge sort, not one or two. So many questions. If you go to the placements also, you will find out many questions. Need not be gate examination, right? If you take the any right competitive exam of computer science, right? If you take the placements also, gate also, many questions are there. So common traps are, some people will think that, some common things are, they will think that merge sort is in place. They will forget the right auxiliary space, extra space n required, right? So expecting different best case, worst case, they will think that best case is different, worst case different. So they will think that it's stability concept, and also please take care of this also. Please take care this also, right? And one more, right, you are expected, right? So one page gate revision summary. So this is the divide and conquer application. Time complexity is n log n, space complexity is n, stability wise yes, in place no, best for linked list. This is the right, these are the small points. But I cannot cover the total merge sort in one class. I cannot cover the total merge sort in one class. I cannot cover it. It is actually required 10 hours. Merge sort is actually required 10 classes, sorry, 10 hours required. Merge sort actually required 10 hours. I just completed in half an hour. Because if I completed a half an hour, you may feel that, right, I'm going fast and all. Because if I done only in the half an hour, you may be thinking I am fast. No, it is required 10 hours. Total story is there, 10 hours merge sort, A to Z of merge sort. A to Z of merge sort is available in the actual classes. A to Z of merge sort is available in the actual classes. Try to understand. A to Z, just I'm completed only in 30 minutes. In 30 minutes, I completed the total story. That is the reason you find, that, right, merge sort is very difficult and all. When if I take that 10 hours, which is there in the actual course, you will find A to Z. Oh, it is like that. Main points I underlined. I said main points. Merge sort, main points I said. Right? So new batch is started just today, right? If you start today, within 2 months, you will complete the total theory, plus 2 more months, you will complete the practice. You will be so good in the DSA. You will be so good in the DSA. It is simply explanation, major points of the merge sort. Major points of the merge sort I written here, right? Perfect. Reconciliation is 2tn by 2 plus n, which is n log n, right? Stack space is going to be log n, overall space is going to be n plus log n, which is n. Because of more than log n, it is not in place, it is out place, right? And one more thing is comparing with other sorting algorithm. This is the relation. Comparison with other sorting algorithm, comparison with the sorting algorithm, in place, out place, all the things are there. In place, out place, all the things are available, right? Please check here. Check everyone compare. Little doubt also there. Please see everyone. Everyone, I have to understand this. Small doubt also there. You let me know. So those people who want to prepare the DSA course properly, you can go for DSA course for placements with internship. You can go to this course, right? So next one, DSA course with the system design, right? You people can go there. Both, anyone you can select. Anyone. And one more thing is 60% discount going on. 60% discount going on. Please utilize. 60% discount going on. Please utilize. If you keep on delay, you never study DSA. If you keep on study, you never study DSA. Please try to understand. If you keep on study, you never study DSA. My sincere request to all the people, right? Start now. If you are not good in DSA, please start now. Please start now. Thank you. Thank you. See you in the next class. Just, it's only for introduction. It's only for introduction. Sir, I'm starting like DSA only because of your teaching. Thank you. Thank you so much. థ్యాంక్ యూ. థ్యాంక్ యూ రేడియంట్. థ్యాంక్ యూ సో మచ్. హాయ్ సార్, ఒకసారి తెలుగులో మాట్లాడతారా? రాకీ సేయింగ్ తెలుగులో మాట్లాడతారా? హాయ్ రాకీ. రాకీ, నేను నిన్ను మిస్ అవుతున్నాను. రాకీ, నేను నిన్ను మిస్ అవుతున్నాను. గుడ్ ఈవినింగ్. గుడ్ ఈవినింగ్ సార్. లాజికల్ లెర్నర్ ఈజ్ సేయింగ్ గుడ్ ఈవినింగ్. గుడ్ ఈవినింగ్ లాజికల్ లెర్నర్. Radiant is saying that because of you only DSA I am studying and all. Thank you so much, Radiant. Thank you. This only, right, just half an hour. I want to give glimpses of merge sort algorithm. Main points I written the main points. I didn't said everything. I just written the main points, merge sort algorithm main points. Right? These are the main points. Everything I written here. Everything I written. Main points I written. Right? So some traps also. What are the traps can be? Traps also I written here. I written the traps also. Fine. Let me know if anyone having any doubt. Those people who want to be expert in the DSA, I request you, new batch started. In that batch you can happily join. 60% discount going on, utilize within right 2 months syllabus completion, 2 months of practice. Within 4 months you will become a expert. Within 4 months you will become a expert. Yeah, thank you, see you in the next class. Thanks everyone, see you in the next class. Tomorrow we are going to discuss. Either quick sort or heap sort. Tomorrow we are going to discuss about quick sort or heap sort. Please try to understand. Tomorrow I am going to start either quick sort or heap sort. Yeah, thank you all. Bye everyone.